Ever since we started to make indexable thread mills, we have been asked the question, which is better, solid carbide or indexable? And this has been going on for years now. So it is time to settle this question once and for all. So let's see how a solid carbide multi-row thread mill holds up against an indexable tool. We start with the dimension M20 and we machine a low alloyed steel. Well, we have reached approximately the same machining time. So to answer our question, we need to dig deeper. We need to look at the cost per thread. In this chart, you see the machine cost and the tool cost. The machine cost depends on the machine hour rate and the machining time, and the tool cost depends on the tool price and the tool life, or insert price and tool life. Since both tools are equally fast, the machine costs are the same. However, we see that the indexable thread mill has a significantly lower tool cost. And this is because one set of inserts is comparably cheap and each insert has 3 cutting edges. But we also need to consider that you have to buy a tool body for the indexable thread mill. However, since the tool cost for the indexable thread mill are significantly lower, the tool body will be amortized after about 2,000 threads or 2 sets of inserts. But so far, we have not included reconditioning in our calculation. If you send the tools to us for regrinding and recoating, the tool cost for solid carbide thread mills will go down because reconditioning is less expensive than buying a new tool. So here's the chart with 1 reconditioning cycle, with 2 reconditioning cycles, and with the recommended maximum of 3. And in this scenario, you would need to go through more than 20 sets of inserts before the tool body of the indexable tool is amortized. To sum it up, if you don't want to do reconditioning, you are better off with an indexable tool. If you do reconditioning, solid carbide is the first choice. But what about larger dimensions? Let's have a look at the dimension M24. Again, we have achieved approximately the same machining time, so the machine costs are also the same. As for the tool cost, if we calculate with 3 reconditioning cycles, we would need to go through 5 sets of inserts or 5,000 threads before the body of the indexable tool is amortized. If we do not consider reconditioning at all, the body of the indexable tool will be amortized after a single set of inserts. Long story short, the larger the dimension, the better it is to use an indexable tool. While in the dimension M24, reconditioning still decides whether it's best to use a solid carbide or an indexable tool, in the dimension M30, indexable is clearly the first choice. So have we settled our question by that? Not quite. There are 2 advantages of indexable thread mills that we have to consider. First of all, if we have unstable machining conditions, you can switch to inserts with anti-vibration geometries. So we have a tool that runs really stable even under poor conditions. Second, while most solid carbide thread mills are designed for a single pitch, the tool body of an indexable tool can be used to machine several pitches. The M24 body, for example, can be used for a 1.5 mm pitch, a 2 mm pitch, and a 3 mm pitch. You just need to select an insert with a smaller edge radius for the small pitches. So let's sum it up. Up to the dimension M24, reconditioning decides whether it's best to use an indexable or a solid carbide tool. Starting from the dimension M30, indexable is clearly the first choice. However, indexable tools cope better with unstable machining conditions, as you can use anti-vibration geometries, and tool bodies of indexable tools are more flexible because they can do several pitches. We hope that this comparison helps you to make the right decision for your workshop. Thanks for watching.